Okay, now I will show you how to solve this problem. Okay, uh, PPT is visible or not? This PPT.
Yes, sir. Yes.
Okay, you see here, this is the truss structure. Its modulus of elasticity is 1.9 into 10 raised to 6, and area of each member is 21.5. Now this is 8.7 feet. This is 24 feet. Now this is supported at these two ends. Okay, and these are the members. Now what you have to do, you have to find the coordinates of this all the points. Here this point, this point, this point, this one, and this one. Okay, now it is, you take 0 0 here at this location 8.7 feet, and here you have to take the mid node. Here also you have to take the mid node. Okay, and this is from this side it is 8.4. Okay, 24 minus 8.4. Now I will show you how to solve this one. I will open hypermesh. Already I have selected OptiStruct. Now first step is material. Now I will give the steel. Okay, color, I will select the color. Next type is isotropic. Card image is matte one. It is same to the last problem. Okay, click on create edit. Now here you have to enter the properties. Now properties are 1.9 into 10 raised to 6. Okay, 1.9 into 10 raised to 6. Now E is 1.9 E6. Okay, 1.9 into 10 raised to 6. Now return from here. Sorry, one thing I have to I will update it. Still select, update and edit. Poisson's ratio is remaining 0.3, and density not necessary to do it, but I will do it. Okay, return from here. One material is created. Now next step, here in this case area is given, dimensions are not given. Directly you can assign the area to the properties. Okay, hyperbeam step for this rod element you can skip. How we can do this, I will show you. Here directly go to the properties. Now enter the name for the properties. I will write here truss properties. Truss, I will define the color. Okay, next type is 1D. Card image is P rod. Material is steel, and in place beam section you keep blank and click on create edit. Now here you have to enter the area. Have you got this step? Here and area is 21.5. 21.5, because cross section of this truss members is not given. If cross sections are not given, then you can enter direct area for that cross section. Because see here, if it is a rod element and when we apply the tensile or compressive load, then what will happen? Then area will not affect. That means cross section will not affect on the stress and deformation. Okay, just area is important, cross section is not important, because your stress equation is force upon area, not cross section parameter is not used for calculation of the stress. Okay, now return from here. Property is created. Okay, now each step we have removed. We have created MP, then you go to the C component. Okay, now next create the component. Now I will write the name truss component. I will use color. Next properties which we have created. Okay, and it has no card image. Click on create. Have you got it? Any doubt here? Avanti Nalode, have you got it?
Yes, I got it.
Okay. Now next one, after doing this, you create the component. For see this geometry. Here I am going to take origin. Okay, that is first node is at 0 0, second node is at 8.7. Okay, 0. This node see here, this is at 24. How much it is? This one. Okay, I will write here. I will make it in slideshow mode. Here 8.70. This one, it is from this side. 8.7, 24 minus 8.7. How much it is? 24 minus 8.7. How much it is? You tell me. How much it is? This is 24 0. 24 0. X coordinate is 24, y coordinate is 0. And this is 24 minus 8.7. It is 16 point something, na?
15.3.
15.3. Okay, 15.3. Now this coordinate not necessary to calculate. This coordinate, this is a 4 feet, 4.4. That is y coordinate is 4.4, and x coordinate is half of this. It is 12 and 4.4. Okay, 12 and 4.4. Or now I will develop the model like this. Okay, now you see here, I will create the nodes. Go to geometry page, nodes. First node is at 0 0. Click on create button. Okay, and press F key. That will come at this location. Second node is at x is equal to 8.7. Again click on create. Third node is at 15.3. Click on create. Next node is at 24. Click on create. Now these nodes are created. Here 4 nodes I have created. Now here I will create one middle node. Now it is at 12 and x coordinate is 12 and y coordinate is 4. You see this image. X coordinate is 4 for this. Here for this node, it is x coordinate is 12 and y coordinate is 4.4. 4.4 this dimension. Okay, so I'm going to create y coordinate is 4.4. Okay, and create. Now these nodes I have created. Have you got it? Now what I want to do, I want to create the one node in between these two nodes. One node between these two nodes. So that, see here there is one option in node creation. This option. It is interpolate nodes. Interpolate nodes. Here I am going to create one node in between this and this node. Okay, and say create. You will get one mid node at this location. Again I will repeat this. You see here, go to nodes, select this interpolate node option. Interpolate node option. Okay, initially you are here. You select this option, interpolate nodes, enter the value here 1, select the node between which you want to create the node, this one. Okay, create. This is one option. One more option is there. You see here, in geometry page, select the distance option. Distance option, and between two nodes, select this node and this node. Okay, now you will get the distance here, and you click on node between, you will get the node between these two nodes. Okay, have you got this operation? Any doubt here? Have you got it? Yes किंवा no, you give the reply. अरे रिप्लाय द्या ना, येस किंवा नाही म्हणून सांगा. कुणाल पाटील.
Got it, sir.
Okay. Now see here, this is not theory, this is a practical. You have to give the reply, otherwise how I can go to the next? Okay, now you create the rod elements between these two. Go to the 1D, select the rods. Okay, you select the property first, truss, element type C rod. Okay, select this node and this node, you will get C rod here. Select this node and this node, select this node and this node. Directly it will create the node rods, this node and this node. Select this and this, select this node and this node, select this node and this node. Okay, then you have two more elements, these two. Okay, this element and this element, same thing you repeat. Select this node and this node, this node and this node, again this node and this node, select this node and this node. Have you got the structure like your truss structure? Okay, if Kunal Patil, have you got it?
Yes, sir.
Okay, can I go to the next?
Yes, sir.
Now what is the next step? Now we have created the component, our component is ready. Now next is you have to apply the load. Now go to the load. Sorry, before that we have to create the load collector. Click on load collector. First you have to create the SPC. Okay, it has no card image. Select the color. Okay, and say create. Okay, now here one load collector is created. Now it is active. Now here after creating that SPC, you can apply the constraint also. Okay, now you go to the analysis page, you select the constraint, select this node and this node, these two nodes are fixed. Okay, now I will increase the size. Have you got this? I have created SPC, I have not created the forces. These two nodes I have fixed. Okay, I will return from here. Now I need to apply the forces. Now what are the forces? Here 250, 250, 250, 250. Everywhere there is a 250. Okay, now I have to apply the forces. Now for application of the force, because before application of the force you should have force collector. Now go to the force collector. Here you enter the name force, it is a load collector, and say create. Now this character is created. You check whether it is active or not. Okay, you check it whether it is active or not. Okay, you see this one, it is active. Here you can see this is force active. Now return from here. Now apply the force. Go to analysis page, go to the forces. Now where it is on all these nodes at up 250. Now this is the node, this one, this one, this one, this one. So here you can apply the force at a time on all nodes, and it is in y direction. Okay, and how much magnitude it has? It has 250 magnitude. So here it is unit consistency, not necessary to change the units, and it is minus y minus 250. Okay, and say create. You can see here this model. See here, this is over. If you have doubt, you can ask me. If you are not getting anything, I will delete it and again I will do it. I will show it. Any doubt here? Yes, Kunal Patil want to ask some question. Do you want to ask, Kunal Patil?
No, sir.
Pranjal Patil, sorry, Pranal Patil. Pranjal Shelar, do you want to ask?
Please upload this lecture on YouTube.
Okay, I'm going to upload it, but here if you are doubt, you can ask me. Already I have uploaded yesterday's 2 sessions on Moodle. Okay, this also I am going to upload. Okay, but you have to attend here, that also better for your understanding. Okay.
Yes, sir.
Now after doing this, what you have to do? You define the load step. I will go to the load step. Here I am going to give the name as truss analysis. Okay, now it is also linear static analysis. Okay, now SPC I am going to select as a SPC. Okay, now you can change the color of the force. I will change it to the yellow. Okay, and load I am going to select as a force. Okay, and say create, or return from here. After doing this, now everything is over. Here material we have created, properties also we have created, component is also we have created. Okay, load collectors we have defined, load step also we have defined. Okay, now after that you save it. I will save it as a model. Now I will make a folder for it. It is truss analysis. Okay, and here it is also, I will give the truss name. Okay, save it. Now run this model. For running this, you click on solver OptiStruct. Okay, now here export option is all, run option is analysis, and click on OptiStruct. Now it is going to start the solving. Now solution is over. Now see the results. Here it is unsupported graphics card, because I don't have graphics card in my laptop. Okay, now I will go to the XY plane. Now again I will make it in 3D mode, visualization, rod, cylindrical, click OK. Now see here, this is a truss structure. Over. Now I will go to the displacement. This is contour. Click on contour, select the displacement here, and click on apply. Now see here you will get the displacement. Here you have high displacement. Okay, it is maximum displacement. This is 0. Maximum displacement is 9.3 into -4. It is high, means it is not big displacement, it is a small displacement, but because of this color it is going to show this maximum displacement as compared to these two displacements. Here it is maximum. That means in this area you have maximum displacement, high displacement. Now if we go to the stress, go to elemental stress, select the averaging method to simple and click on apply. Now see here you will get the stress variation. Okay, have you got it? Now maximum stress, here negative stress is -2 point. Every stress is negative. Why? Because we have applied force in negative direction. Okay, And if you observe the animation, you see this one. Now displacement is very small. It is in terms of the, you can see here, it is in terms of 10 raised to minus 4. So we will not see the animation with the help of 1:1 scale. We need to modify the scale. I will give here 100. See this one. Okay, I will increase again. Is it visible? Is it visible? Have you got it? Shivam Bhoskar?
Yes, sir.
Okay. Now this truss problem is over. Now I will go to the next. I will close this. This is the Hyper-V window. I can close directly. No. Next one. Now I want to open new window. Now for opening new window and for removing all these things from this window, that is for opening new project, what you have to do, you go to the file and click on new model. Okay, click on new model. When we click on new model, this everything will be removed from this window and you can get new fresh HyperWorks window. I will click on this one. You can see here. Now next part is, I have already told you that this rod element is not going to support a bending load. Now I will show you how it is not going to support to the bending load. Okay. Now in truss structure you have only tension and compression. Okay, but when we apply the bending load, you will not get the appropriate. It will solve the model, but it will not give the appropriate results. Okay. Now I will show it by taking simple problem. Here these are the contents of my this topic or this analysis. Rod element subject to bending force. It is not going to support the bending force. So I am going to repeat the steps. Now you tell one by one. First step is material. Now I will select the create option. I will give the name steel. Next I will define the color. Now its a type is isotropic. Card image is matte one, and click on create edit. Now here E is, I will keep E as it is because this is not part of your what we can say, it is not part of your experiment, but I am going to show how that rod element is not supporting to the bending load. Okay, this is 0.3 and this is 7.9 into 10 raised to minus 9. Click on return. Material is created here. Next one, after creating the material, what you have to do, you create the hyper beam. Now I will go to the 1D page. I will create the hyper beam. Now I am going to take the rectangular section. Here I am going to take solid rectangular section and say create. Okay. Now I am going to take the random dimensions. Suppose 100 by 100. Okay. Now you take these dimensions 100 by 100. It is a square section having dimensions 100 and 100. Okay. Now I will go back to the model view. This cross section I am going to use for my rod element. Okay. Now I am going to back hyper mesh window. Now here section is created. Now return from here. Next one, now create the properties. Now here I will write bending of rod properties. Here color I will keep as it is. It is 1D element. Next card image is P rod. material is steel, beam section which we have created, that is rectangular section, and check it, create and edit. Here area is defined and polar moment of inertia or moment of inertia is also defined. Okay, because we have created the beam section. Return from here. After doing this, you create the component. Here I will give the name rod bending. Okay, now see the properties. Bending rod, click on create. It has no card image. Create. Next, return from it. Next, after creating the component, you have to create the model. For modeling, you go to the geometry. So here I am going to create simple model and I am going to apply the bending load. That means in first or yesterday I have shown you rod element subjected to tension. Here I am going to show you rod element going subjected to bending. Okay, and I am going to show how it is not going to support bending by showing the results. Okay, now I will create the nodes. First option I am going to choose. Here I will create 0 at 0 0, say create. Next I am going to create second node at 500, say create and press F key. Okay, to fit in the view. Now return from here. I am going to create the rod element from these two nodes. Rod, here properties and element type C rod. Select this one and this one. Now rod element is created in between these two. Okay, I am going to use only one element. Return from here. Okay, now in 1D page rod element is created. Now I am going to create the load collectors. For that purpose, go to SPC, load collector. Here you enter the name SPC. Okay, now next you click on create. Return from here. Okay, now next is go to analysis page. Apply the constraint here. Constraint on the first node. I am going to fix all degrees of freedom. Click on create. Here I am going to increase the size. Okay, or now next one. Next is I am going to apply the bending load. For that purpose, you create the load collector again. Here force. Now I will change the color. Click on create. Okay, now go to the force. Select here second node and I am going to apply here minus 10,000 suppose. Okay. Click on create. You can see here this is a bending load on rod element. It is not beam element. It is a rod element. Now after that I am going to define the load step. Now for defining the load step, go to load step. Here I will give the name rod bending. Here you can give any name. Set the type as a linear static. Go to the SPC, load as a force and say create. Okay, load step we have created. Now everything is over. Now I will save it. File, save as a model. Now I am going to create one more folder, rod bending. Okay, now here I am going to give the rod bending now name. Okay, click on save. Or now I will run it. Run here. Export option all, run option analysis. Click on OptiStruct. It will run. It will show the results also, but that results are not obeying the theory of the bending. Okay, you can see here. Now in xy plane, now I will go to the check the displacement. If I apply the displacement, you will get it is minus 10 raised to 14. You can see here. Now here you will not get. If I go to the stress, elemental stress, and simple click on apply, you can see here you will get the 0 stress. Have you got it? Any doubt here? Any doubt here? Kunal Patil लक्षात आलं का? It is showing 0 stress. Why it is showing 0 stress? Because we have used the bending applications for rod element for bending applications, but rod element is not going to support the bending load. Okay, Kunal Patil.
sir.
Have you got it?
Yes, sir. Yes.
This rod element is not going to support the bending load. Okay, and if you observe the displacement, see here I have applied 10,000 load, and in under that load also you are not getting the stress. Okay, you are not getting the stress. You can increase the load and then also you can check. You will get the 0 stress because that element is not going to support the bending load. Okay, now which is the appropriate element for bending? Okay, that we will discuss now. Now here it is the same step. I will close this. Now again I will go to the new model. Okay, in PPT what I have completed this rod element and solving the rod problem by using 10 rod elements, that you can do. Okay, and that will not affect on your solution, because if we have stepped bar, you have to go for multiple elements. If it is a problem having single cross section, then not necessary to go for multiple elements. Now you tell me, is there any doubt in the first topic? This one. If you have doubt in the first topic, you read this. I will explain again. This I have covered. Yes. कोणाला डाउट आहे का पहिल्या ह्याच्यात? First part. And why you are not giving the reply? If you are not getting, you tell me. You are not getting. Pranjal Shelar.
Yes, sir.
Is there any doubt in first topic, that is this one? This one?
No, sir.
Sir, I have problem to ask everyone. If you have doubt, you can ask me. If you don't have doubt, you can tell me, sir, go ahead, no any doubt. Okay.
Okay, sir.
Okay. Now can I go to this, how to create bar elements?
Yes, sir.
Okay, and I will explain all these things. First, bar elements related to tensile force. Okay. Now see here. Here, bar element, actually bar element is used for bending loads, and when we use bar element for tensile load, it will calculate the results and it will give the results. Okay, can you do yourself? It is same to the rod element. I will go to the next point. If I skip this one, you can do yourself. Okay, that is first part. If you can do this one, it is same to your first problem, this one. Then I will go to the next one, this one. Can you do this one? Or is it necessary to explain this one also? No reply. Yes. Can you do this?
So I am not able to, sir. View the PDF, sir.
ओके ओके
सर पीपीटी दिसत नाही सर.
दिसत नाहीत काय? ओके ओके I will share unshare again and I will. Now is it visible?
Yes sir, visible.
Visible, sir.
Okay. Now it is in not in PowerPoint mode. What happens? Is it in PPT mode? Is it visible?
Yes, sir.
Yes sir.
Okay. Now see here. What I want to say you here, this I have covered. Okay. Now this first point in this one, it is bar element subject to tensile force. It is same to this one. Just element we have to change. We have to change the element. Okay. In place of rod, we have to select bar element. Okay. Now if you are ready to do this one, then I will go to the next point. So I want your feedback. If you are ready to do the first point, I will go to the next point. Are you ready? If you are able
sir.
to do this one, I will go to the next point. Okay. Now concept of okay, I will show you. Okay, I will show you. Now I will go to bar element subject to bending. Okay. Now tensile force you do yourself. Now select the material. Again you select the steel. You can choose yourself. Now you see here. This is the problem. Bar element subject to bending force. Okay, bar element subject to bending force. Okay. Now here you have analytical solution. Okay. Here you got the stress 300 Newton per millimeter square, displacement 2.38. Okay. Now bending stress, all of you know. Now I will go to this one. Still, I will select the color isotropic matte one, create edit, same procedure. E, new and row. So here if you want to change the material, you can change from here. Okay. Return from here. Again return from here. Next one. After creating the material, you create the beam section, hyper beam. Now I am going to select the standard section, solid rectangle section. Now what I want to do, in place of 100 by 100, I will select the 100 by 200. Is okay. It is 200, and this one is 100. Okay. Now I will go back to the slides. Is it visible? Slides are visible or not? Whether slides
Visible sir.
Okay. Now see here, I am going to explain the concept of CDEF point. CDEF point. What is concept of CDEF point? I will tell you. You have studied the theory of bending. Now in theory of bending, what you have studied? Here you have neutral axis at this location. Am I right? If you have this beam and it is fixed at this location, okay, and when we apply the load at this location, it will deflect like this. It is going to deflect like this. Okay, do you agree with this? And whatever bending stresses you get or you got in this beam, here upper portion of the beam is subject to tensile stress. Am I right? Upper portion of the beam, it is going to subject to tensile stress. Okay. Now, as it is a cantilever, and lower portion, it is subject to compressive stress. Okay, compressive stress. And one more thing I want to tell you here, your stresses are changing from this point to this point. Okay, your stress equation, you have bending equation m by I is equal to f by y. Okay, already you have studied this. It is equal to E by R. E by R. Okay. Over. Now, if we consider first two points or first two terms in this equation, this one, m by I is equal to f by y. Here, this f is a bending stress. F is a bending stress. If we write the equation for the bending stress, it is f is equal to m by I into y. That means your bending stress is varying with y. Y means distance from the neutral axis, and it is for cross section. Now, if we consider the different sections, if we take the section at this location, at this location, then this bending stress is also varying with the bending moment. That means along the length, it is not constant. See here, in place of this one, if we consider the rod element subject to tensile load, and if it has uniform cross section, then stress is constant from this end to this end. But for bending load, it is not constant from this end to this end. Okay, do you agree with this? And one more thing, this bending stress is also varying from neutral axis to the extreme fiber. Okay, do you agree with this? So we need to define these points, C, D, E, F points. Okay, C, D, E, F points. What are the C, D, F points? If we define the cross section of the beam, see here, this cross section of the beam is must for beam applications in hyperbeam window. Okay, C, D, F point. Here, this point is C point, this point is C point, this point is D point. Okay, this point is E point, and this point is F point. This point is F point, and on the beam, this point is C point, this point is D point. Okay, this point is E point, and this point is F point. Okay, I will show you again. See here, these points have very important significance. Here, this is a C point. See here, this is your hyperbeam window. Okay, beam window. Okay, and this is your mesh, mesh window. Okay, now here we are creating the length, and here we are creating the cross section. Okay, now properties of the beam are changing with the cross section, so we need to give these points. Now C point is this one. It is in YZ coordinate. This is Y axis, and this one is Z axis. Okay, this is your D point. Or now if we consider this in YZ coordinate, here Y coordinate of this C point, it is half of this distance. It is half of the just minute. Hello sir, आज प्रॅक्टिकल चालू आहे, काय प्रॉब्लेम होता? ANSYS इन्स्टॉल केले, पण बघायला पाहिजे आता, चेक करा. बरेच दिवस बघितलं नाही. ANSYS पायरेटेड आहे आमच्या इथं. जरा चेक करा, नाही तिथे इन्स्टॉल केलं तरी चालतंय, काय प्रॉब्लेम नाही. कोणाच आहे? चेक करा म्हणून तिथं खाली. होय आम्ही प्रॅक्टिकल घेतली तिथं. हा मग तुमचं हा. Okay, now this is a C point, this is D point, this is E point. Okay, E point. Now here's this y coordinate of this C point, it is half of this distance. Okay, half of this distance, and here D point, and Z coordinate is 0 here. Z is 0, y is half of width height of the cross section. For D point, here width of cross section divided by 2 is Z coordinate and y coordinate is 0. Okay, here it is minus half of the y, that means half of this cross section, and Z coordinate is 0. Okay, here it is y coordinate is 0 and Z coordinate is half of the width, half of width. Okay, why we have to define these coordinates? Because when we go for the beam analysis, at this location we have maximum stress. Okay, at this location we have maximum stress, and at this location we have zero stresses. Here you have zero stress. Okay, here you have zero stress. Now if we orient this in the same way, that means if we consider this cross section as it is, and if we orient this in z direction, this z axis will be your vertical axis. That means this will tilt in this direction, at 90 degrees. Okay, now your this F point will come at this location and D point will come at this location. Okay, this is a CDEF point. Where is this? This is a CDEF point. I got it. Now I will show you it on hypermesh. Okay, now here if we consider the point at this location, it is your C point, okay. Here this is a point D point, this point is E point, and this point is F point. Now you see, you can observe this one, it is y axis and this is a z axis. It is y axis and this one is z axis. Now if we calculate the coordinates of this point, this is C point, coordinates of this point, here if this dimension is 200, then coordinates of this point, y coordinate is 100 and z coordinate is 0. Okay, because this point is on y axis. Now if we calculate the coordinates of this point, you will get the y coordinate 0 and z coordinate half of this one, it is a 50. Okay,
50.
Yes, and if we calculate the y coordinate of this point, it is your E point. Here y coordinate is 100 and z coordinate is 0. Here here y coordinate is minus 100, not 100, minus 100, and z coordinate is 0. At this location your F point is there. Here y coordinate is 0 and z coordinate is minus 50. Have you got this? Here these coordinates are important and we have to enter these coordinates in the properties of the cross section. Okay, any doubt here? Okay, if you have doubt you can ask me. Concept of CDEF point. Now one thing I want to tell you here in beam sections, orientation is very important. If we orient this beam cross section as it is, that means in y direction, then this y will coincide with the y of the beam. Okay, y of the beam. That means here orientation of this and this is matching. That means this y will coincide with this y. Okay, this is your x, this one is your x. Okay, and this is y. If your orientation of the beam is y, then cross section y coordinate or y axis of the cross section will match with the y axis of the beam. If we take the orientation in z direction, y axis of the beam will match with the z axis of the cross section. Okay, now how it will be happen, I will show you. Now whether this screen is visible or not? Reply.
Visible,
Whether
sir.
have you got the concept of CDEF point?
Yes, sir.
Okay, I will ask it. Now I will go to the model. Okay. Now I have created the beam. I have created the beam whose dimension in y direction, that is vertical dimension, is 200, and horizontal dimension is 100. Now I will go to the properties. Beam is over. Now I will go to the properties. Go to properties. Here, bar element, bar. I will select the color. It is also 1D. Now here, this is a different card image. For card image, you have to select the P bar. Okay, because we are using bar element. Okay, so you have to select the P bar. Now material is steel, and beam section is created section. Have you got what we have to change it? Card image we have to change P bar. Okay. Now you go to the create edit. You go to the create edit. Now see here, this we are using for bar element. Here we have got area, but we need to define the just a minute. Hello, प्रॅक्टिकल चालू आहे माझं. का हो? कोण बोलताय? माझं प्रॅक्टिकल कितीला संपणार? 3ला संपणार, 3ला. बरं परत करतो की. Can we continue this practical, because now it is 1:30. If you have taken the lunch, we will continue it.
No, sir. We are not.
Okay. I will not close this. I will keep as it is. You can join after lunch at 2 p.m. Na? Am I right?
Yes, sir. Yes.
Okay.
Yes.
Yes, sir.
You can leave the this. You can join